written in lots of different ways, but here's one. So the things I'm likely to ask you are to list a handful of the terms so you know what it is, to tell me what you think it's approaching or what it's converging to. So 1, list some terms. 2, increasing, decreasing, non-increasing, non-decreasing, monotonic, a bunch of words all for the same thing. 3, what does it converge to? We're actually going to prove what these things converge to in the not too distant future, but not this time. Okay, so what are some of the terms? What's the first term? What do you get if you put 1 in here?
1.
Yeah. A sub 1 is 3 minus 2 over 1, which is 3 minus 2, which is 1. And A sub 2 is 3 minus 2 over 2, which is 2. A sub 3 is 3 minus 2/3, which is 2 1/3. A sub 4 is 3 minus 2/4. 3 minus a half is 2 1/2. Okay, what can you tell me about it?
Increasing.
Strictly increasing, right? It's increasing. 1's less than 2, 2's less than 2 1/3, which is less than 2 1/2. When you get confused, put them on the number line. That's a 1. That's a 2. 3's out here. Here's a 3 1/3. Here's a 4. So you figured out it was listed of terms. You decided it was increasing. You don't have to write any proof of this. I'll show you in a second how to write a proof of it, because that's what you're going to, after you take the test and say, wow, I should put some problems up on the board. We're in sequences and series, so that's the next step. But let's go ahead and do the intuition first. What does it converge to? What's this getting close to? Right. N goes to infinity. What does this part go to? 0, right? 2 over infinity is heading towards 0. 2 over a large number is near 0. So this thing is getting closer and closer and closer to 3. So not asking you to prove that now, just asking you to guess what the limit is. So we say it converges to 3, and a way to write that down in the language that you've thought about before is this. Right? And since this part is heading for 0, the whole thing is heading for 3. That's the language we would use. Okay. Now you don't have to do this on the test, but let's prove it's increasing. Take us about 3 steps. Increasing means that the nth plus first term is bigger than the nth term for any n equal 1, 1, 2, 3, ... Increasing means, take any number you want, a million, then the millionth term is less than the millionth plus first term. That's all it means. So a sub n plus 1, no matter what integer you pick, the next one is bigger than the one you're looking at. Simple, right? Okay, well what is a sub n plus 1 according to my formula? 3 minus 2, so let's write it like this. So let's be careful. So a sub n plus 1 bigger than a sub n. I'm going to write question mark, because what if I'm wrong? What if it's decreasing? So I'll write question mark. Well, then is 3 minus 2 over n plus 1, is that bigger than 3 minus 2 over n? What can I do with that inequality? Well, they didn't let you out of college out by accident. You guys are the smart ones. What can I do with that inequality?
consider it.
I just want to simplify it. What can I do?
You like move the 3 over to the, you put them on the side that they come out like 3 with the 30 and the 30.
Yeah. Yeah, let's move the 3 over to here. How do I move the 3 over to there? I subtract it. What's 3 minus 3? It's nothing. Okay. I like that idea. That was good. Andrea, what can I do next?
On a common denominator.
Ooh, that sounds like a lot of work. I'm lazy.
Flip and multiply.
I don't like the, yeah.
Cross multiply.
Cross multiplying is dangerous with inequalities. Because if you multiply by something negative, you switch the inequality, right? So let's just first, I don't like the negatives. Let's get rid of them. Multiply both sides by a -1, right? So that leaves me with 2 over n plus 1, switch, less than 2 over n, right? Now I really am going to do what she said, get a common denominator or cross multiply or something. I'm going to multiply. Is this number positive or negative? Positive, because I'm only allowed to plug 1, 2, 3, 4, 5, ... into it, right? So n plus 1 is always positive. So 2 is less than 2 over n times n plus 1. And n is positive, so I can multiply both sides by n also. Good? Good? I multiply both sides by n plus 1. That's legal, because it's positive. I multiply both sides by n, which is really the equivalent of cross multiplying, right? Now what do I have? I have 2n less than 2n plus 2. Subtract the 2n, 0 less than 2. Now, that's a true statement. Now, so far, I really had question marks the whole way. We talked the other day about how it's possible to start with a false statement and end up with a true statement. So the only way this is a proof is if I can reverse every one of these steps. Is 0 less than 2? Yes. If I added 2 into both sides, I'd get this step. If I factored out a 2, I'd get this step. If I divided both sides by n, I'd get this step. These are all reversible. I can go through all of them. They are all reversible, so I can go back up this way. So if I wanted a proof, I'd have to start here. Follow up to the top, and then I could conclude that a sub n plus 1 is bigger than a sub n for all n equals 1, 2, ... So a sub n equals 1 to infinity is increasing. Questions in my algebra steps?
You multiply by n plus 1 and n in the same
Yep.
step.
Right. Well, not in the same step. First time I multiply by n plus 1, so it canceled on this side. And then that's what I ended up with. Then I multiply both sides by n to get rid of this one. And the only danger is that you'll cross multiply wrong. See, 1/2 is less than 2/3, right? So if I cross multiply 2 times 2, I get 4 less than 1 times 3, which is 3. That's not true. Cross multiplying is a little bit danger. If you do it this times this and put it on the left side, it's less. When it's equal, it doesn't matter how you do it. But when you cross multiply with inequalities, it matters. But it's always safe to multiply both of these sides by 2 and multiply both of these sides by 3, because 3 is a positive number and 2 is a positive number. So that's why I didn't cross multiply. I just did it in 2 steps. Good, Johnny? Okay, so this is not on the test. These 3 are fair questions on the test. We good on all 3 of these? Okay. You said sequences and series, I think. Series are the same kind of thing. Sum n equals 1 to infinity of, I'll make it alternate just to be evil. 3 over 2 to the n minus 1. It's still just a matter of writing out what terms. What are the first few terms of this? Put 1 in for n. What do you get? Let's see, -1 to the first times 3 over 2 to the 0. That's my first term, right? Which is -3.
Yes.
My next term is -1 squared, 3 over 2 to the 2 minus 1. So that's plus 3 halves. And the next one is plus -1 cubed, 3 over 2 to the 3 minus 1. So that's plus, oops, that's minus 3/4. Right. So I've written out the first 3 terms. One of the things I said I wanted you to know about series was how to write out the first few terms. We've done that. So this is what we call the first term. This is the second term. This is the third term. The third term includes the negative. So those are my first 3 terms. Now, the partial sums is what we do next. The partial sums are, how do you figure out what something really adds up to? Well, you add up the first one. S1 is just the first one. S2 is the sum of the first 2. So now I get -3 plus 1.5. So that's -1.5. -3 halves. S3 is -3 plus 3 halves minus 3/4. So me being the multiplying whiz I am, -12/4 plus 6/4 minus 3/4. That's -12, -15, -9/4. Okay. This is not one I expect you to be able to guess what it converges to. So far they all look negative, but those are what are called the first partial sum, the second partial sum, and the third partial sum. So the definition of partial sum is the nth partial sum is S of n, which is just sum from n equals 1 up to that n of a sub n, right? Partial sum just means add up the first n of. First partial sum, add up the first. Second partial sum, add up the first 2. Third partial sum, add up the first 3.
So you
I
just,
think I'll make my grading easy and just give you one problem and have you add up tell me what the 100th partial sum is. Okay. Questions? Good? Tyler? What you worried about?
Sequence 3. I was trying to read that.
This one?
Yeah.
It's supposed to say third partial sum, S3, is negative, just the sum of these, -3 plus 3 halves minus 3/4.
Mhm.
So then all I hope I did was get a common denominator. -3 is -12/4. Then multiply this one by 2 over 2, 6/4, -3/4. Then I hope I added right and got -9/4. All right? So that's the definition. And we say a series converges if the sequence of partial sums converges. That's the definition. Do these numbers add up to be something or not? The question is, we say yes if you list this sequence and you can figure out what that sequence is going towards. We say no if that sequence either goes off to infinity or it might alternate. For example, suppose I have this series. What's that one equal to? The first one is -1.
+1 minus 1.
Now, does that converge or not?
Does it convert?
If it converges, it should go to 0, right? Because, I mean, common sense would say, well, these two are 0. But now look at what the partial sums are. What's the first one? -1. What's the next one? 0. What's the next one? -1. What's the next one? 0. Does that sequence converge? Is it heading towards a number? No, it alternates back and forth. -1, 0, -1, 0. So that sequence, that diverges. So there's a sequence that a series. This series diverges because the sequence of partial sums diverges. Good? Masters of all things sequences a series? Intuitively, they're really easy. And that's why I wanted to make sure you studied them before the test. I throw a couple easy problems on there for you. It just says, list me some terms, tell me what the partial sums are, get you used to plugging the numbers in. Intuitively, they're really easy. Proving things about them, not quite so easy. But we'll get there. Yes, sir.
Only a problem, when do you know to put the limit?
When do you know to put the limit? If it says, if it's an improper integral, you've got to use a limit. So the question really is, if you have a definite integral, let's see if I can make one read. This is not an improper integral. Why not? Because I can plug anything between 0 and 3 into this, right? The only place this is undefined is at -2, and I'm only studying it from 0 to 3. With me? So this is a definite integral. Definite because it's got these endpoints. But it's not an improper integral because there's no place where I'm interested in where it's undefined. Make sense, Dominic? You good? Okay, so now, did you get what you wanted? So how do you know, what you asked was, how do I know when to use limits with improper integrals? The answer is, if it's an improper integral, you'd better use a limit. So if you've got the integral over x minus 2 from 0 to 3, 2 is in between here and here, that's an improper integral. You have no choice but to use limits. And so on this one, if I were to look at the graph, undefined at 2, looks like that. I'm going from 0 to 3. So I'm going to have to look at this area and this area separately. With me? So I got to break it up and say I'm going to look at it as the integral from 0 to 2 of 1 over x minus 2 dx plus the integral from 2 to 3 of 1 over x minus 2 dx. I've chosen a really boring example. I should have made it. Well, let me just, it's just as easy. But I think we've done one just like this one. And all this switches is this, okay? But there's another major change that occurs. That other one's boring. It was a natural log. You're going to plug it in. You're going to get infinity. It was going to have undefined area. This one's going to have defined area. So now I have to look and say, okay, 0 to 2. I'm looking right over here. It's defined at 0. It's not defined at 2. So this one becomes the limit as pick any letter you like. I don't know. I'm going to pick t. T goes to 2 of the integral from 0 to t. And it's going to 2 from the left of of 1 over x minus 2 squared dx. This one's going to be the limit as t goes to 2 from the right of the integral from t to 3 of 1 over x minus 2 squared. Dx. Did I get it right so far? Okay, so pick one of these. I'm not gonna worry about it. Which one do you want? Left or right? Okay, let's do left. It's bigger. If it exists, the other one does, right? Right? These are symmetric. I guarantee you, from 1 to 2 is the same as from 2 to 3. So if this one exists, you know this one exists. So if you're only interested in whether it exists, do the big one. Okay, so somebody said do the left one. So here I go. This is now, can I integrate that? How about negative x minus 2 to the negative 1? Because the derivative of that would be this times this, which would be positive 1 x minus 2 to the negative 2 times the derivative of the inside. Got it. So that's equal to the limit as t goes to 2 from the left of this evaluated from 0 to 2. You with me, Dominique? Took the antiderivative of this. Endpoints go in, subtract the top one minus the bottom is the rule. I've still got to do the limit. So that's all in there. Plus star, this guy's star, right? Which I'm not going to do. You guys don't pay. So now I put that in, and it's negative 1 over t minus 2 minus negative 1 over 0 minus 2. So it's the limit as t goes to 2 from the left of negative 1 over t minus 2 plus minus 1/2. Minus a minus a minus. Right? Minus, minus, a minus. Now, what happens to this guy as t goes to 2 from the left? Oh, darn. I thought I made one that worked. It's going to blow up, isn't it? Oh, yeah, t goes to 2. This thing gets closer and closer to 0. This thing gets closer and closer to infinity. What'd you do wrong? Oh, I know what I did wrong. This is fine. Sorry. Okay, so this becomes heads towards infinity because as t gets closer and closer and closer to 2, this gets smaller and smaller and smaller in the bottom. The whole thing gets bigger and bigger and bigger. So that blows up, so undefined. So we say this integral diverges. And the same thing would cause this one to diverge. Should have left the one no, the one I had was blown up too. There you go. You do enough of these, you figure out the powers. But,
You gotta put the divergent part in this too?
pardon?
You gotta put the words on the.
All I care is that you get to here and tell me that that limit doesn't exist. So this integral, what you're supposed to know is that that means that this area is not only unbounded, this area is unbounded, or this region, let's say it precisely, this region is unbounded and the area is infinite. The fancy word the mathematicians, big dogs use is they would say, this integral diverges. That's what they would say. So I don't know when Brandy likes you or not. She might give you a little plus 0.5 or something. All I care is that you know that it's undefined. Okay. Good? Other test questions? Mm-hmm.
I was having trouble with problems like finding the integral of like x squared times the square root of something that's not
Perfect squares.
It wasn't a cube? Where the derivative of the inside is down here?
Mhm.
Okay, I just made one up, let's see if I can do it. The problem with making up integrals is you can't always do it. Okay, u is 4 minus x. Make sure that's real close to that, so it doesn't look like it. So du is negative dx. Problem, I'm guessing the problem you're having, Jesse, is that if I need to get rid of this x squared, so let's solve this. So that means u minus 4 is negative x, so that means 4 minus u is x, so that means 4 minus u squared is x squared. That's my guess as to where you got in trouble. You've got to make everything go away, right? So you've got to translate everything. And the funny thing is, I had one of these on the test, and I can't remember if I replaced it or not. I several integrals I thought were too mean. I took them off. I don't remember if that's one of them or not. Sometimes I make up examples of the board, and there's a reason they come to my head. Okay, so this is integral 4 minus u quantity squared, square root of u. Dx is negative du. So that's negative integral. There's no way to avoid squaring this out and then multiplying it by that. So that's, do the algebra up here. 4 minus u squared u to the 1/2 is 16 minus 8u plus u squared times u to the 1/2. So down here I have a 16u to the 1/2 minus 8u to the 3/2 plus u to the 5/2 du, which you can do. Good?
You know, good stuff on the, going from x 4 minus u squared, then also get it back on
Yeah. Everything has to be converted to u's, no matter which of these two expressions you use, everything in there has to become u's.
Next question. Looking for the derivative of the inverse secant.
Is d always gonna be equal to negative dx?
Pardon?
Is it always gonna be opposite signs for those two?
No, I'm taking the derivative of both sides. So the derivative of u du, the derivative of this side is negative 1, then dx. So it's really, what I mean is negative 1 times dx. So I wrote negative dx. Remember that I think of du meaning the derivative of u and dx meaning the derivative of x. I'm actually thinking of this in my head like this. This is a function. U prime of x is negative 1. And you can write this whole thing in terms of using u primes, but it takes a little more time, and if the engineers didn't use this notation, I wouldn't. But I feel obliged to use a notation that you're going to see a lot of the next few years, no matter how bad the notation is. All right. Okay. Well, it's like somebody was about to ask something.
Yes, sir.
Dylan, you have one?
What if we could do the derivative of arc secant or secant to the negative 1?
I can try. I never promise I can do it. I have bad days too. F of x is the arc secant. So the secant of f of x is x. The derivative of secant is secant tan. Derivative of x is 1. So f prime of x is 1 over the secant of f of x times the tangent of f of x. This eraser, I can do it with one hand behind my back. Feeling confident today. You with me, Dylan?
Yes, sir.
All right. So now, secant of f of x is x. So that's x, that part's done. So f prime of x is 1 over x tan x. Now that tan x could be a little harder to get rid of, but not much. Secant of f of x is x. That means 1 over cos of f of x is x. That means cos of f of x is 1 over x. God, I took a trick. Right? That means I can draw a triangle. Cosine of the angle is adjacent over hypotenuse. I thought somebody was throwing stuff at me. So, how'd I do? Adjacent over hypotenuse, square root of this squared minus this squared.
Yeah, that's right.
So tangent is now opposite over adjacent, which is just that. So there I am. Yeah, document doesn't make you derive it. He just makes you do application. He is an undergraduate engineer. But you don't have to drive things in his class. You got the worst of both worlds. He made you do the apps, I'm going to make you do the derivations. All right, we good?
For doing intervals with just trig identities, if you have an answer that has like a double angle in it, does that make a difference as opposed to like trig substitutions where you shouldn't have double angles? Because I'm having trouble like figuring when to use the double angle triangle. Like there was one of the practice problems, and the answer was like sine something 2x.
Mhm.
But if it was a trig substitution, probably I know that.
You'd have to get rid of that.
Right. So I wasn't really sure like when do I.
You don't need to get rid of it unless you have to get rid of it. The thing that happens is sometimes you made a substitution, t equals something, right? And then you end up in terms of t's. You have to get back to x's. Well, the only way I know to get that back to, if you make t is equal to sine of x here, then you don't know what sine of 2t is. But, I mean, x equals sine t. If you made the substitution x equals sine of t, so now everything's in terms of t's, right? And you're stuck, you don't know what to do, but if you wrote this as sine 2t, which is 2 sine t cos t, now you know sine t is x, and you can use the triangle to figure out what cos t is.
So it's only if you change the variable.
Right, it's only if you change a variable that you end up having to use that double angle. That's right. Okay, so let me show you something neat. So, if I wanted to find this, if I want to do this improper integral, I wanted to find out what's the area trapped under this curve. F of x is 1 over x. From 1 all the way out to infinity. Then this is what I'd have to do, right? And we'd be doing an improper integral, so I'd say I got to get rid of that infinity, which was Dominique's question. If it's an improper integral, I always have to use a limit. So I've got to replace this with the integral from 1 to n of 1 over x dx. Thankfully, I recognize that as an easy integral. So that's the limit as n goes to infinity of natural log of x, evaluated from 1 to n. That's the limit as n goes to infinity of natural log of n minus natural log of 1. Natural log of 1 is 0, but this tends to infinity because the natural log function looks like this. and it goes off to infinity. So diverges, undefined. Some people would actually just write infinity. There is a way to make that precise. You can define a set of numbers as all the real numbers in the world, along with two numbers that we'll call infinity and minus infinity. And then you can define addition and subtraction and do all kinds of cool things. They're called the extended reals. We didn't do it in here. I'm not going to do it. But you can use the word infinity and pretend it's a number. And mathematicians have made that precise. Okay, so what did I just figure out? I figured out this here area is infinite. All right? We already knew that. I think we'd already done this one, so not a terribly revealing thing. Now I'm going to spin that area. Those of you who had Dawkins got lots of practice doing this. Those of you who had me have never seen this before. I'm going to take this curve and spin it around the x-axis. When I spin it around the x-axis, thanks to my amazing graphical skills, it looks like this. Right? And it goes on forever. Good? I want to find the volume of that tube. I'm going to find the volume of that tube. Now, what should it be? It should be infinite, right? Because this area was infinite, and I spun it around. Okay. Here's how I'm going to find the volume of that in less than 10 minutes. I'm going to remind you first of the most important thing from Calculus 1, which got glossed over right in the last 3 weeks when you were completely brain dead. And that's that the integral from a to b of f of x dx is the limit as n goes to infinity of the sum What do I mean by that? Let me draw a picture. Here's a function f from a to b. Hopefully, whoever you had for calculus made you do some what we call Riemann sums and add up rectangles. And say the area under that curve is approximately equal to the area of those rectangles. And if I add up those rectangles, and I call this x0 and this one x1, x2, x3, x4, then the area of any one of them, like that one, is x3 minus x2 times, pick any height you want, f of x3. The height here, if here's x3, then that height is f of x3, so that's the area of that particular rectangle. Make sense? And when you write the sum, it just means add them all up, right? So you add up these rectangles, but what I want to do is sum infinitely many, right? Make the rectangles smaller and smaller, and so the width smaller and smaller and smaller, because you get better and better and better approximations when you do it. So that's the definition of the integral from a to b of a function. Okay, now I'm going to come over here, and I'm going to start breaking this up. I'm going to say, okay, here's x0, here's x1, here's x2, here's x3. Let's just figure out the volume of this little piece right here. What does that look like? Pretty close to a cylinder, right?
Mm-hmm.
It's squished, but it's pretty close to a cylinder. I'm going to draw it bigger for the people in the back. From x2 to x3, that's the width. So if I want to find out the volume of this cylinder, turn it on its side, x2 to x3. What's the volume of that cylinder, that one piece? It's the volume of cylinder. 4/3 is spheres.
3/4
1/3 pi r cubed is like cone.
pi squared each. The base times.
Area base times height. Area base times height, what's the base? Circle, so it's gonna be pi r squared h, which is pi. Okay, what's the area of the base? What's the radius of the base? Well, it's f of x2, isn't it? Because this is the height, this is a function, f of x is 1/x. So if I put x2 in there, it's f of x2 times the height, which is x3 minus x2. Got lots of time. That's just one of them. What are all of them? The sum from I equals 1 to n, if I wanted to add n of them out here to number n, would be pi f of x sub I times x sub I plus 1 minus x sub I. So what did I do? I just added up n of these. There's the first one, 1. There's the second one, 2. There's the third one, 3. All the way out here somewhere to the end. Are you convinced? Are you convinced with me that I've got the volume of each one of those right? I mean, now I'm cheating, right? Because it's not really a cylinder, is it? But now, as the width of these go to infinity, and using this formula here, if I take the limit of both sides as n goes to infinity, so if I take the limit as n goes to infinity of this, that is by definition the integral from 0 to infinity, because it's going out forever, of pi f of x dx, right? This definition, this part becomes the dx, that part's my f of x, the sum becomes my n. So this says that volume is nothing but an improper integral. Factor out the pi, replace f of x with 1/x. Hey, you guys let me make a mistake. I'm going to fire y'all and get a new class. What did I do wrong?
Your interval numbers.
Interval numbers I think are okay. X of I plus 1 minus x of I, x3 minus x2, x2.
But you're saying from point A to point B, but you might say how many segments between point A and point B.
That's true. I'm being really, so if I'm thinking of n is out to like the integer n, 1, 2, literally the number 1, 2, 3, 4, 10, and I let that go to infinity, then I'll be integrating out forever. I see what you mean. My interval, I don't want an endpoint. I want it to go to forever. But that's a good question. What's the formula say? Pi r squared. I didn't square it. The radius is f of x, right? But I didn't square it. F of x is 1/x. I know that because remember earlier I told you it wouldn't come out. Okay, so now I'm going to integrate. I think I just did this one almost. Negative x to the negative 1. Put your limits in, Ted. Don't cheat them out of their limits. Oh, not from 0, from 1. Negative x to the negative 1, we negative times a negative, which is positive x to the negative 2, right? Equals pi times the limit as n goes to infinity of negative 1/n minus a negative 1/1. Pi times the limit as n goes to infinity, negative 1/n plus 1. What's this go to as n goes to infinity? 1. What's the whole thing then? Pi. Now that's surprising. The volume in here is pi, right? According to what I did. Unless I made a mistake, the volume in there is pi. On the other hand, one slice of the inside, if I slice this thing all the way down the middle, the area of that slice is infinite. Now that would appear to be unbelievable. I've got an infinite cylinder, right? Getting smaller and smaller and smaller. If I slice it down the middle, I can never paint even one slice of the whole thing because it would require an infinite amount of paint. But if I turn it on its end and I pour paint in, it only takes pi gallons of paint to fill it. And if you fill it, it would seem like you painted every slice in there, right? Seems highly suspect, right? Bad thing to do right before a test. Makes you believe that all mathematics is kind of suspicious. I'll let you think about that over the weekend. We'll talk about it more after the test. It's kind of it's neat.